Here are the answers for the Day 3 bell work. Question A. When 50 milliliters of water containing some hydrochloric acid at this initial temperature is mixed with 50 milliliters of water containing sodium hydroxide at that same initial temperature, in a calorimeter, the temperature of the solution will increase to this new higher temperature. How much heat in kilojoules is released by the reaction? The reaction is contained in a device called a calorimeter, and a thermometer is inserted into that device. The calorimeter contains water, and when the chemical reaction occurs causing heat, the temperature of the water will increase. Based upon how much the temperature of the water changes, we can figure out how much heat is released by the chemical reaction. And that's done with this math formula here. Delta H of the system is equal to the negative of the mass of the water times the specific heat of the water times the change in temperature of the surroundings. Delta H represents change in enthalpy, or another way to think of it, change in heat. That's what we're asked. So we have a question where we have to figure out the answer for delta H. That means we need to substitute values for the other three things. Let's fill in M, the mass of the water. How much water is being heated? Well, we're told that there's 50 milliliters of water with the acid, but another 50 milliliters of water containing that base. So in total, in the calorimeter, there's 100 milliliters of water. Each milliliter weighs 1 gram. So if there's 100 milliliters of water, there are 100 grams of water. Now let's multiply by the value of C, the specific heat of water. Recall from an earlier bell work that that is 4.18 joules. The specific heat of water can also be thought of as 1.00 calories, but I'm using the value in joules because I see how the problem wants me to give an energy that's in kilojoules. Finally, delta T. How much did the temperature change? Well, the initial temperature was 22.5. The final temperature was 26. If you subtract those numbers, we see that the temperature increased by 3.5 degrees. Multiply these three numbers together to find the change in heat. The value on the calculator is negative 1,463 joules. Remember that we're asked to figure out kilojoules, not joules, and we're asked to figure out how much energy is released. The fact that this is a negative sign means that the system is losing the energy. It's releasing the energy. So we could answer this question by saying 1.463 kilojoules of energy are released. To change joules into kilojoules, you divide by 1,000. A way to think of that is moving the dot 3 positions to the left. Because this is a negative value, that means that the system, by that I mean the reaction that's happening in the calorimeter, is releasing the energy. So here's how much energy is released. Question B. A small pebble is placed in a calorimeter containing this much water at this starting temperature. The water reaches a maximum temperature of this higher value. How many joules of heat are released by the pebble? To answer this, we want to use the same formula. Delta H is equal to negative M times C times delta T. The question asks, how many joules of heat are released? That's the delta H, the change in heat. Let's substitute for M, C, and delta T. M is the mass of the water. Let's figure that out. We're told that the calorimeter contains 25 milliliters of water. If there are 25 milliliters, then the mass is 25 grams, because 1 milliliter of water weighs 1 gram. The C is the specific heat of the substance water. In joules, that's 4.18. The delta T is the temperature change. If the water started at 25 degrees Celsius but ended up at 26.4, then the temperature changes 1.4 degrees. Multiply these on a calculator to get the result. And the answer is negative 146.3 joules. This time we're not asked to change to kilojoules, just leave it as joules. The fact that this is a negative number means that the system, that is, the pebble, has lost that energy. The surrounding water has gained that energy, and that's why the water's temperature went up. So to answer the question, I'm going to say that 146.3 joules of energy are released. The pebble gets cooler, and the surrounding water got warmer.